Okay, let's talk about this rich aunt problem. I want to make sure you guys understand what's happening here. So what's happening is we have this aunt and she's going to give us $1,500 at the end of each year for 6 years. So she wants to put all that money into an account and it's just going to automatically give us $1,500 every year for 6 years at the end of the year. But so you might think at first like, oh, she's giving us $1,500 every year for 6 years. So she's really just giving us $9,000. And while that's true, she doesn't have to put $9,000 into an account because that money is just going to be sitting into an account and earning interest, right? So this is going to be in here for, well, part of it's going to be in there for 1 year, but parts of it are going to be in there for up to 6 years. So we're getting interest every time. So if we just think about like, what about that first year? So think about your, and we've got annual interest here, right? So N is 1. So if we want to get $1,500 at the end of the year, just after 1 year, how much money does she really have to put in there? So R was 8%. How much money does she really have to put into that account so that by the end of the year we've earned $1,500? That's going to be the same thing as solving for the what's the present value, right? So we could divide both sides by 1.08 to find that present value. So we could write that as 1,500 divided by 1.08, or the way the book does it is 1,500 times 1.08 to the negative first power. And that's going to be the amount of money she needs to put into the account for that first year, right? So that works out to, if you cared about the actual value, works out to about $1,388.88 or 89 cents. So just think about it if it was just 1 year. If it were just 1 year, she only has to fork out $1,388 in order for us to, at the end of the year, get our $1,500. So she's not going to need to put in the full $9,000. How much is she really going to have to put in to fund this account? Well, the answer is after the first year, that's what this chart is saying, this first year, we have this 1,500 times 1.08 to the negative 1. That was the $1,300 we just found. She's going to need to put in that for that first year. In the second year, we could do the same sort of calculation where in the second year, we want to get $1,500. So how much would she be putting in if we want, after 2 years, to have $1,500? And so we see that it's going to be 1,500 divided by the 1.08 squared. Right, that's going to be how much money we need in order to have. So, and again, if you wanted to get a number sense for that, it's about $1,200, well, almost $1,300. Right, so we're going to have the amount for the first year, the amount for the second year, amount for the third year, all the way up to the amount for the sixth year. And so if we add up all of these values and factor out the 1,500, we have the 1,500 times the 1.08 to the negative 1. Same thing to the negative 2 power, to the negative 3 power. So we're taking advantage of that we have this property of, if we take something x to the negative 1, x to the negative 2, plus x to the negative 3, right? We had this formula that we did some algebra for. It's equivalent to this expression right here. It's the 1 minus x to the negative n, right? But in this case, x is 1.08 and negative n is negative 6 over x minus 1. And so we can work out that, in fact, the aunt really just has to contribute $6,934.32 into this account, and not the full $9,000, because this money will earn money over time, and so we will still get $1,500 each year for the 6 years, with that as being the investment.